Well, now that this rig has a nice new paint job on it, it's pretty much undrivable because of how bad it runs. So this truck has a 350 TBI. It originally had a 305 before this motor. They both had the same problem though. Things that have been replaced: the fuel injectors, the coolant temp sensor, the distributor and the module in it, the oxygen sensor down there. The throttle body's been through, cleaned, map sensor's been replaced. Pretty much the only sensors that I don't think have been replaced is that spark control deal and the knock sensor itself, and the computer and the wiring harness. The idle air valve has also been swapped out. This thing just still runs bad, and here's what it's doing. All right, the annoying buzzer has engaged. So we'll just give it a second. It's not doing it that bad right now, but hopefully it comes through in the audio. But what the truck is doing is it's idle hunting all the time. It's not that bad right now, but every now and then you'll hear it stumble down and then pick back up and stumble down and pick back up. And the problem is it is intermittent. But when this thing does it really bad, it will just rev way up and then stall, which is a huge problem whenever you're in traffic. So whatever's going on with this thing, it's intermittent, which makes, solving the problem incredibly difficult, because like right now it's actually running pretty all right. But yesterday when I was looking at it, it stalled 3 times on me. So the only info I have to go off of is at one point it did have a check engine light for the map sensor circuit. So just for giggles, I'm gonna go ahead and check that. So if you're gonna have a GM TBI vehicle and you plan on keeping it long-term and working on it yourself, I strongly encourage you to get one of these factory service manuals. So this one is for an S10 because I have an S10, but the info we're looking for is the same across all of the TBI models. So this book goes through, tells you different codes, shows you the wiring of pretty much everything, how you can check stuff, what it's supposed to do, why it's supposed to do what it does. So having a book like this is super helpful for whenever you want to look at, say, the map sensor in this case. So I'd like to rule out the sensor, that plug at the sensor, and all the wiring going to the computer. So what I'm going to do is, now that I know the pin that I'm looking for, so 5-volt reference, the computer sends 5 volts out to the sensor. The sensor is nothing but a resistor. Pretty much every sensor on these, with the exception of the knock sensor, is some kind of resistor. So the computer sends out 5 volts, it goes through the sensor changes resistance, and whatever voltage comes back is the signal. And that's the input from the motor to the computer, so the computer actually knows what to do with anything. So I'm going to go back probe C11 here on the computer, hook the meter up to it, and see what it's reading. So I'm using these little back probing tools here, and I'm having to use alligator clips with it because I don't have the right leads to actually plug into them. Go figure. But I'm going off of the map sensor signal that's coming back from the sensor to the computer over here. In my case, it is that green wire, C11. This row is C, and then they labeled everything, which is super nice. So C11 is the signal coming back from the sensor, and then this is the ground to the sensor, A11. Should be a purple wire down there. So an absolutely important thing that you have to know before you even think of doing this is how this is set up right here is either going to kill or save the computer. So all these little ports here on the meter do different things, and the circuitry in the meter is different based on how you have it hooked up. So if you're going to be doing this, you need to have whatever your positive lead over here on this side of the meter, where it should show some kind of grounding deal there. Something that basically says, hey, there is an internal resistor in the meter between these two. That way, you don't immediately short and kill the computer. These two over here that are strictly for checking amperage, they don't have that safety in the circuitry for them. So if I moved this over here and turned the power on to this computer, it would immediately be dead. That'd be the end of it, because I just shorted the voltage to the ground and burn up whatever part of the circuit is in charge of doing that. But with the meter plugged in over here, that resistor in the meter will prevent it from being a dead short, and it will keep the computer safe. So you absolutely have to make sure that you have your meter set up right and that you don't go touching stuff together or doing anything crazy. And if you don't do any of that, then the computer should, we'll say should be all right. Obviously, there's always a risk with getting into this stuff. All right, I turned everything on. The computer's still alive. The magic smoke is still in the box, which is good. So according to the manual, sitting here at basically ambient atmosphere, because the motor's not running, we should have somewhere from 4 to 4.6 volts coming back to the computer. So 4.1, we are well within spec, so we're good on that front. And when this thing is running at idle, it should have somewhere between 1 to 1.5, and that's assuming the idle is set correctly. So we'll go ahead and start this thing here real quick. Not sure why I think my connection down here might be a little screwy. It definitely is. So we might be reading a little bit on the low side, but this thing's also not running exactly right. So it would appear, even though this thing is not running right, the signal for the map sensor is still getting to the computer. So the sensor, the wiring, and all that seems fine. So let's go consult the book. Well, just for giggles here, we might as well see what the sensor does, just for our own entertainment. So there you can see, as the throttle opens and closes and the vacuum pressure goes up and down, the resistance in that sensor is changing, and so it's changing the voltage that's coming back to the computer. So the computer can only do as good as it can with the information that's given to it. So that's kind of why the shotgunning parts at it doesn't always work. But in this case, it might actually be the computer. Before I forget, another test I did before messing with this, because I was suspect of the oxygen sensor, since the oxygen sensor is usually the go-to sensor just to throw a new one in. These actually have a really cool, seemingly little known self-diagnostic mode in them. So if you go down to the OBD1 connector, there it is. These first two pins, A and B, these top two right next to each other, A and B. If you jump those and turn the power on with the motor off, that's how you get the codes out of the thing. But if you leave the jumper in there with the motor running, it will put itself into a diagnostic mode for the oxygen sensor. So right now it's going through the check engine light, so it's doing code 12. There's actually no code stored in it right now, which is irritating. But if I go ahead and start it, so now it is in the diagnostic mode for the oxygen sensor. So that quick flashing means that the sensor is in, or that the computer is in open loop. It's ignoring what the oxygen sensor is saying because the oxygen sensor hasn't warmed up enough to give any kind of reliable data. Or something else, some other condition is wrong, meaning that it can't go into closed loop. So right now, this slow flashing means that the sensor is in closed loop. And the whether the light is on or off tells you what the sensor is or what the computer is seeing from the sensor. So there, it just kicked out of closed loop for some reason. But whenever this is flashing slowly, if the light is on more than it's off, then that indicates a rich condition. If the light is off more than it's on, that indicates a lean condition. So I think what happened here is the sensor cooled off, but so you can see even flashes, so it's pretty, pretty much a stoichiometric ratio, but if do you see how the light stayed on there longer? So the light stayed on just a little bit longer, meaning rich. And then when I let off the gas, it stayed off for longer. So that's kind of a cool test function you can do without any fancy scan tool that can also help figure out what's going on. So the reason I'm not even looking at the O2 sensor right now is because this thing runs bad whether it's an open loop or a closed loop. So because of that, I'm ignoring it for the time being. This next test is pretty simple. We're just checking this bit of wiring in that connector. So I unclipped the sensor from the bracket, and I'm just gonna move the whole thing around with the power on and see if the voltage reading changes. The voltage reading, because the motor is not running, really shouldn't be changing. So if the voltage starts moving around a bunch, then we got a connection issue. All right, so let's see if this changes at all. Nope. Seems like our connection and wiring is fine. All right, the next test here, I have the vacuum line going to the sensor undone, and I wrote down my voltage reading from just an ambient pressure, so just atmospheric pressure, and it was 4.5. And then, per the instructions, I used this definitely extremely accurate gauge, put a vacuum of 10 inches of mercury on it, which gave me a reading of 2.37. So I subtracted that from my initial reading and got about 1.8. So 1.8, the whole point of that test is you want to be greater than 1.5. If you're lower than 1.5, then it says everything is hopeless, replace the sensor. So 1.8, we're still fine on that test. Another test we can do here is by quickly changing the vacuum to the sensor. The voltage reading should be an instantaneous change. So I'm going to release the vacuum now. Well, okay, my vacuum release thing doesn't work. So I'm going to add more vacuum to it now. And that appeared to be a pretty instantaneous change. And I'm going to pull the vacuum line off now. So the sensor seems to be pretty responsive. So I think we're also good on that test. Intermittent problems are so irritating. Yesterday I could hardly keep this thing running. Now, runs like an absolute dream. No idea what changed. Also worth noting, I did check that this vacuum line doesn't have any holes in it. It's sealed up good on both ends, and I blew into this end of it and have unrestricted flow into the throttle body. So the map sensor should be getting a good solid vacuum signal from the intake. All right, we got one last Hail Mary here, since everything about this setup has changed except for the computer and the wiring harness. I have a computer. So I took the computer out of my S10 because it runs really good, so let's risk screwing that up. And we're gonna try putting it in this truck. So this talks about just how everything is set up here. So the PROM, programmable read-only memory, that is the chip that actually runs the motor. It has the tune and everything on it. So it's this little guy here, that guy. So that is the chip. So back in the day when somebody would say, oh yeah, I put a 50 horsepower chip in my truck, it was just one of these with a different tune in it. So this even says that the reason they did that is so you could have the tune on that chip, but this part down here, the expensive computer part, could be the same between various different models. So we should be able to get away with just swapping the V8 PROM into the S10 computer and see what happens. Now, if nothing happens, it may mean the PROM is screwed up and I don't know what to do with that information, but there's a chance it gets better. If it gets better, then it's definitely the computer itself. Got it idling in gear here, and it is running pretty much smooth as glass as far as I can tell. Really not having any issues. Well, I don't know if I learned a thing from this experience, but it was definitely interesting. So I took that S10 computer and put it in the truck here, and it ran. It had a really high idle, but it did run. But it was throwing a code saying that the PROM, this guy right here, the removable chip part, saying that the PROM was bad, but it ran. I went back and read through the book, and what the book says is this little guy right there is called the CAL pack, and I guess it's supposed to be built-in redundancy to the PROM. So the CAL pack also has a tune on it, and it's supposed to use the CAL pack and the tune in it if the computer sees that there's a problem with the PROM. What's insane about that is that means somehow this thing was running pretty decent off of a V6 tune, which makes absolutely no sense to me unless, I don't know, that doesn't make any sense to me. So we're just going to chalk that up as a mystery that humanity can't solve for now. And I took this computer, so this is the computer that was in this truck. I left the PROM out of it and ran it, and it ran better than it did with the S10 computer, but it ran smooth, just at a high idle. That's what the clips earlier were showing. And then I put the PROM back in it, ran it again, and it started doing kind of the idle hunting thing, and it was idling a lot lower. So I don't know if that means anything. In my mind, if the CAL pack is supposed to have a tune in it and be the backup to this guy, in my mind, it should run pretty much the same between the two of them. So I don't know. Is the PROM the thing that's bad? Maybe. I think that's what we're going to do, though. Buy a computer, buy a PROM, and we'll start over with this again. All right, got a new computer thrown in it. Still has the old PROM in it, so I guess we'll see if that's working right. There's a fancy tool to pull these out. I don't have one, so I just very gently used a flat blade screwdriver to slowly work that out of the old computer. And just make sure you get it lined up right, because if you bend the pins installing it, then you just wrote the whole thing off. So I found it was easier to start at one end and get the little plastic pieces started just on a corner, and then slowly work it all the way across and down. So it makes a little bit of a kind of crunching noise as they all seat. I'm not sure how you can differentiate between that and ruining it, but I think I got lucky and it is installed correct. All right, good sign here. I went ahead and checked the codes before starting it. It is not giving a code for either the ECM or the PROM or the CAL pack or any of that being bad. It's just giving me code 12, which is normal. So I'm gonna go ahead and unplug this, I guess. Where's that? There. I'm gonna unplug that and see if this thing will fire off. I'll let it run for a few minutes and we'll see what's what. Well, it's actually been 3 months later, and this thing hasn't really had any major problems. It still has a little bit of a weird running deal, kind of like every TBI that I've seen has, but it quit doing the horrific idle hunting, it quit stalling, and overall it just has seemed to run a whole lot better since doing the computer swap. So I guess for once the computer actually was the problem.